Okay, this is section 2, and these are unsaturated hydrocarbons. So remember, unsaturated have double bonds or triple bonds. Unsaturated means they're not completely filled up with hydrogen. And then we'll look at some reactions and some aromatic. We're not going to focus a lot on reactions. And then we'll look at aromatic compounds as well. So alkenes have double bonds, and this is their general formula. That's what they look like. Remember, the general formula for alkanes are CnH2n minus 2. Alkenes have twice as many hydrogens as carbons. And then remember, alkanes are the single bond. So we have alkane, alkene, and alkynes. This triple bond is an alkyne. Okay. We use that in the naming. So this one would be ethene because there's 2 carbons. So this is the simplest alkene because it has 2 carbons. You can't have an alkene with only 1 carbon. So ethene is the simplest and smallest. Okay, so alkynes have triple bonds, and this is an alkyne. Again, this is the simplest alkyne. We're going to use the ene and ine prefix to name them. The formula for that is CnH2n minus 2. So that means for every 2 carbons, you only have 2 hydrogens. And here are the names for it. It's the same as naming alkanes, except you add ene right here if it's a double bond, and you add ine if it's a triple bond. And then you have to also identify where that double bond is or the triple bond. So here you have butene, and the double bond is on that first carbon. You use the lowest numbering again. So this one would be 1-butene. And then this one, the double bond is on the second carbon, so you would name it 2-butene. You can also have substituents sticking off, so you'll have to name those accordingly too. So here's some examples. You again look for that parent chain, and I can see this 6-membered parent chain here is hexene. And then the numbering gets priority with the double bond. So wherever the double bond is, that's going to get numbered first, lowest. Here, the double bond is on the second carbon, so I'm going to call that 2-hexene, and then I'm going to number the substituent. So I'm going to call this one 4-methyl-2-hexene. On this one, we're just looking at the skeleton view, and so each corner or edge is a carbon. On this one, the parent chain has 5 carbons, and you also want to pick the chain, like if it's a tie, you want to pick the one that has more double bonds. If you have 2 chains that are the same length and you can't decide which one's the parent chain. So on this one, you have 1, 2, 3, 4, 5 carbons, and that's a penta. You have 2 double bonds, so we call it a pentadiene, showing that it's 2 double bonds, diene, and then we have to tell where those double bonds are, and we're going to do the lowest numbering. So it looks like 1, it's actually the same either way you go, but 1 and 4, we're just doing the start of the double bond. So this is 1,4-pentadiene. And then after we've done the double bonds, then we go to numbering the substituents. And we see here that this ethyl group is on the second carbon. So that's 2-ethyl. And then this methyl group with a single CH3 is on the 4th carbon. So that's 2-ethyl, 4-methyl, 1,4-pentadiene. We can also number cyclo molecules that are in a circle. So our parent chain is usually going to be the circle, like the cyclo. So here we have, we'll start here. We start at the double bond. So we have 1, 2, 3, 4, 5, 6, 7. So that's going to be a heptene. And we're going to add cyclo to it because it's in a circle. Don't forget the cyclo. And then we're going to say that this is, oh, we don't need to number where that double bond is because we automatically know that we're going to start counting at the double bond. So you don't have to indicate that unless there's more than 1 double bond, which we'll see in a second. And then you have these 2 methyl groups. So this one is 5,5-dimethyl-cycloheptene. This one over here is also a cyclo, and it has 6 carbons, so it also has 2 double bonds. So you start numbering. They numbered to get this chlorine at the lowest too, instead of starting over here and numbering. And also, like if you started here and went all the way around, your numbers would be much bigger. So try to get the smallest numbers. And you have hexadiene, because there's 2 double bonds. You add the cyclo, and then you're going to indicate where the double bonds are. So they're on carbon 1 and carbon 3. And then you're going to indicate that the chlorine, we haven't done halogens yet, but this chlorine here is on the 2nd carbon, so you call that 2-chloro. So here's some exercises. We'll try to name these. Here we have a parent chain of 1, 2, 3, 4. Can you put those up, please? Okay. So we have 1, 2, 3, 4, 5, 6 carbons in a chain. So that would be a hexene because we have a double bond, and then we number the double bond. So it would be 2-hexene because the lowest number is starting from this end. And then we identify the methyl group. So we have this methyl group, this one, and that one, and it would be 2, 3, 5 trimethyl 2-hexene. There it is. Okay. This one, our parent chain looks tricky. Our parent chain is here and coming up. Okay. So let's count 1, 2, 3, 4, 5, 6, 7, 8. You have 8 in that carbon chain, so that would be octene. And then you're going to prioritize that double bond in your numbering. So here we have 1, 2, 3. It's on that 3rd carbon. This one's just a substituent. So we're going to call this 3-octene, and then we number the substituents. So we have a methyl group here on the 3rd carbon. That's going to be 3-methyl, and then 4, 5, 6, an ethyl on the 6th carbon. So the name is going to be 6-ethyl 3-methyl 3-octene. Here's some reactions of alkenes just really quickly. You can add H's to go from an alkene to an alkane, to go from double bond to single bond, and they do this to our vegetable oil. And then you can also add halogens, which we saw. So we have like a double bond here. We're going to add a bromine, and we get it's brominated now. So you can pop those double bonds and make it all single bonds. And then we can also join a bunch of them together to make polymers. Okay, so here's some other types of unsaturated hydrocarbons. We've seen these at the beginning of the year. They might look familiar. So aromatic hydrocarbons are not like, that's not a word that means like that they smell pretty. It means that they are cyclic, they're circles, and they are unsaturated. So they have double bonds and they have really strong aromas. And so we've looked at some of these. The simplest one is benzene. We saw these at the beginning of the year when you guys did your projects of harmful chemicals, and a lot of the stuff had benzene. So a lot of these are really dangerous. This is your basic one, and this is kind of what the structure looks like. It's a cyclohexane, and then every other bond has a double bond. To name them, there's some special names, but we draw it like this. This is the symbol for benzene. It has a cyclohexane with a circle. So we can call this chloro, benzene. This one's actually called toluene, bromobenzene. This is a phenol, nitrobenzene, styrene, which makes styrofoam. So we can actually substitute and add substituents and name them that way. We can also add more than one substituents, and we would use similar naming techniques. So this is pretty easy after you've done the other stuff. If you have 2 bromines right next to each other, you just indicate where they are. 1,2-dibromobenzene. So you can see how we name some of those other ones. And then these are some uses of these benzene rings. You can use them for naphthalene, which is like a insecticide. You can use them for dyes. You can use them for explosive synthesis of drugs. They have a lot of different uses, and you see them everywhere. And most of the time, they're not super safe, but they're useful. And once we figured out how to make benzene, as you guys learned, I think from before, you can make a ton of different materials with them. So, all right, I hope that was helpful.